Now let's continue our exploration of basic Linux commands. So thus far we've covered some of the more common commands through stat. So let's continue discussing these important items. Now to make a directory, use make dir. Creates a directory. And if you supply a file name, then it simply creates a directory relative to the current directory. So for example, make directory temp makes a directory relative to our current directory in the current directory. Whereas make directory temp2, for example, makes the directory temp2 or named temp2 beneath the temp subdirectory. So make directory creates directories as needed. Notice also that directory entries for this file system causes the entry to occupy 4096 bytes. You may also execute stat against directory items, not just standard files. Stat returns all sorts of useful information, including its name, its size, the number of blocks it occupies on the disk, and the I/O blocks represented 4096 in this case, as well as the device's location, the inode occupied. Each file within a Linux file system occupies a distinct inode. User and group ownership information, same information shown using ls-l, for example. And the all-important access, modify, and change times. Notice that the times are all the same because the object was made at once. But if we update the object, let's touch, for example, temp, then follow that up with a stat of temp. Notice that the timestamps have now been updated to reflect the current time at that particular time. So touch changes these items on the object. Access, modify, and change, or it creates a 0-byte object. So make directory creates a directory wherever you specify, and conversely, remove directory removes a directory, or remove with the RF option. So removes directory recursively or file as indicated. So to remove this entire structure, we could, for example, use remove directory temp. That's one option, but because it's not empty, it prompts us. So if we try to move the directory beneath it, then it removes it. We'll echo the exit status, which by the way is stored in the question mark variable. And whenever you see 0, that means the recently run command ran successfully. And now let's remove directory temp, and it removes it. Now let's remake the directory structure again. History grep make dir, and 117 followed by 119 will recreate the structure temp2. Remove rf followed by temp will recursively remove the tree, and an echo of the exit status returns 0. Let's just note that that's also an important incarnation of the echo command, and that's with the question mark variable. It reveals the recently run program's exit status. So for example, echo question mark returns exit status of recently executed command, which may not necessarily be 0. And if it's non-zero, it means you'll need to consult the documentation of the command to determine what the problem at hand was that was encountered by the program. So remove directory are other commands. Now you may also export variables to your shell that you reuse for other purposes, perhaps in scripts and otherwise. Let's say you want a variable such as conf directory. So set grep for a variable name like conf will return anything that's defined. Supposing we wanted to define a variable calling it conf directory and setting it to etc. Using export followed by the name of the variable, which normally within bash shell environments is uppercased. So conf dir setting it equal to etc. This will make available, so publishes variable to current shell, and more specifically the current TTY. So when you export the name of a variable and a value, variables are exported as name-value pairs separated by the equal sign. And that variable becomes available for your usage in the given shell. Let's try to copy that again and try to paste that in this window. So now when we echo or set grepconf, we see we have a variable defined called conf_dir, which means throughout scripts and in general navigation of the shell from this particular TTY pseudo terminal number 2, we can take advantage of conf_dir. So for example, cd conf_dir takes us immediately to /etc. Let's go back to our home directory, lsl conf_dir, or any program that runs within a shell environment will do so. And we can append directories such as conf_dir and let's say SSL, for example. So it uses or interpolates the variable and places it accordingly. So variables can be exported on a per shell basis using export from the command line. And let's just note as accompanying commands we could, for example, lsl conf_dir. We may also simply cd or otherwise into conf_dir and take advantage of the variable however we see fit from the shell. Now this begs the question, how do we ensure that the variable persists across invocations of shells? So that involves using an editor or a program such as Echo to send the export into one of the startup scripts. In each user's home directory, which is represented with tilde, there are a number of hidden files. One of those hidden files that's of importance is bashrc. Bashrc can be used to define variables such as conf_dir. So if we nano, and that's an editor, shell editor, tilde, which is our home directory, .bash, and that's there are a number of files. Bashrc, there's also bash logout, what bash does when you log out of a shell, and bash history, which keeps track of the commands that are executed. So bashrc, and then include in it the following export. Then every time a shell is launched, this variable will become available. So that's what we'll store in the file. So let's modify bashrc, and we'll make some space towards the bottom. You can also place the variable exportation wherever you see the current export. So if you search the document using Control W for, let's say, export, and nothing's set. And sometimes you'll see comments regarding whether or not you should export variables in a different file, such as bash profile, for example, bash_profile. If there's no pointer to that, then just place the export in this file. It'll be read nonetheless. So we'll include a comment. Most Linux-based systems will accept hash marks as comments, so we'll just note that this is a Linux CBT Deb6x entry. And we will paste our exports. So upon subsequent shell invocations, meaning when we launch other pseudo-terminals 3, 4, 5, and 6, and through n, for example, this variable will become available. Now before we save the document, let's launch another pseudo-terminal. So now here is pseudo-terminal number 3. Let's try to echo conf_dir, the variable. Notice it's not set. Let's try to change into conf_dir as we've done from pseudo-terminal number 2, and notice it doesn't work. And the exit status is clean. However, that's because conf_dir is unset, so it's blank. So changing into blank simply means to change into your home directory. As a test, let's change to the root, and then let's change directory to conf_dir again. And because it's blank, notice it places us right back in our home directory. So that's the behavior. However, once we save this file, bashrc, and then relaunch a new shell, let's close pseudo-terminal number 3 and relaunch with Control-Shift-T. There's a new shell. Let's echo conf_dir, and now the variable is set, so that means cd into conf_dir. Now, by the way, the bash shell supports tab completion, so all I simply need to indicate are the most unique items associated with the variable, and then press tab, and the variable is automatically completed by the bash shell. So typing in uppercase CO followed by n is requisite, because there are other variables that begin with CO, such as color term, comp_key, and so on. So CON does the trick, followed by tab, and then it completes it for us, and now we're in the etc directory. So subsequent shells as launch will behave accordingly. And similarly, if we were to log into the system as a different user and then sun as LCBT, so long as bashrc is read, then the file will be processed, which begs the question, what about for existing shells? How do we ensure that existing shells are updated with bashrc? Well, you can source bashrc, which will export the variable. So for example, in this pseudo terminal, there is no conf dir because it was initiated before the saving of the variable definition to bashrc. But if we source home directory, which we're currently in, bashrc, this will do the trick. And now let's echo conf dir again, and there it's set. So one way to rerun and incorporate the changes within a startup config file for bash is to use the source command. The source command executes the contents of a file, incorporating any variables that are set. So bashrc. So this incorporates the contents of the file into the current shell. We'll indicate shell with uppercase variable reference because there is indeed a variable called shell. Another way, or an alternate means of running this command, is to simply execute source by indicating a single dot followed by the location of the file to be sourced. This is an alias or an alternate means of doing the same thing. So alias to source command, which performs accordingly. So if we had a shell that didn't have conf dir, then we could do it that way. For example, if we unset conf dir, and let's just check our variables here, and it's actually not set as $. Let's unset conf dir and then echo it, which brings up another command, yet another command. So let's just include that as well. So you may also unset variables using unset followed by var name. So for example, unset conf, and it's habitual to indicate the $sign when referencing variables. So unset unsets the variable, and alternately we can source using a single dot followed by our home directory where we're currently located, followed by bashrc. Then let's echo conf dir, and indeed it's now set to /etc. So you can set variables using export. You can also set using set. You may also unset using unset, which ensures that the variable is no longer available. That brings up another command, and that's history, which you've seen us use all along. The history command enumerates the history of commands executed up to n commands, and n is configurable, and it varies depending on distribution. So simple history enumerates to the screen, to stand it out, the commands that have been executed. So far here are 76 commands that have been executed. The first being df-h, which enumerates the various file systems down to history, the most recent invocation. So it shows us all of these commands. Where it becomes interesting is when we use history in conjunction with grep to search for specific commands, or when we reference commands from the list using either the most recent invocation via exclamation mark followed by the unique portion of the command, or exclamation mark followed by the number of the command. So supposing we wanted to execute the 72nd command, one way to do it from the history would be to use exclamation 72. This executes the 72nd command from the history. But be very careful when using this sort of reference that you do not execute a command from your history that, unbeknownst to you, inadvertently removes data trees or directory trees. So you may have a remove rf somewhere in the structure that ends up deleting your directory tree if you're in the wrong directory, for example. So let's echo, or in this case, exclamation 72. And there you see that it reruns the echoing of conf directory. So you can access commands from the history by either using the listed number or the most recent invocation, such as exclamation echo, and that echoes conf dir, or exclamation ec, which is unique. And this instance conf d without the r is more recent than the one with the r. And then when you arrow key up in the bash history, it simply shows you the various commands from the history. Now we know that per user a history file is maintained because we saw it as we were tabbing out files. Here's the bash_history file. It's currently 853 bytes. Let's less the contents of bash_history. And indeed, here are the various commands, with the first being df-h through all of the most recent entries. Now, there aren't 853 lines. Some of the commands exceed a single byte. Many of the commands exceed a single byte, which is why the file occupies 853 bytes, such as this long line, which occupies a number of bytes. So this is our history file that's constantly being updated by the system. And if you grep case-insensitively, grep is yet another command which we'll look at in a separate section, for history from all of the files, let's say the bash-related files, you will see various references to the history size, for example. So it's a variable that's maintained, hist size. In fact, if you echo or set grep hist, you'll see a number of variables that are defined. So hist size is 500. That means 500 commands will be remembered, which can be altered, by the way. You can simply export the history variable, or the hist size variable, that is, to be something other than 500. There's also a file size, which is noted and can be updated accordingly. And the hist file, the name of the hist file, which is in the user's home directory, who's currently logged in, and is named .bash_history. So by default, 500 entries are maintained by the bash shell in this particular invocation, which should prove to be enough for most situations. In some distributions it's set to 1,000, in others even fewer. Depending on what's necessary to make your environment go will determine how you take advantage of this particular command. Now, some other useful commands. We've mentioned that there are pagers. Let's look at one pager, and that is less. Less is a pager, and in fact we've looked at less, so let's look at more, the converse. Similar pager, more. So more is another pager. So for example, supposing we wanted to look at one page full at a time, the system log file in var log messages. So more var log messages enumerates one page full at a time of this file, and allows us to navigate through the file accordingly. Now, varlog messages, if we enumerate the contents, in fact, if we try to stat it, varlog as a non-privileged user, we'll see that the file is readable by anyone who belongs to the group, the GID for admin. So our group, we don't belong to the group admin or ADM, so as a consequence we should not be able to interact with the file. This is yet another command, ID. ID enumerates the various IDs associated with a given user. By default, it enumerates the groups and user IDs of the currently logged in user. So let's just include that as well. So 23 ID enumerates UID and GIDs because there's a primary and any number of secondary groups that users belong to. So because we don't belong to admin, which is the group that owns the file, we should not be able to look at the file, but let's try it anyway. More var log messages. Notice permission denied. So we need to be root or belong to the admin group. One way to circumvent this is to sun, which defaults to suing it as root, and then execute more var log messages, which will allow us to take a look at the file accordingly. So now we see that the file is displayed one page full at a time. As we can see, we can space, and a percentage is displayed towards the bottom, which indicates the amount of data that have been displayed of the file, so a percentage of the file as it's represented. So we space ahead 3 pages, and that's 1%, 6 pages, 2%, and we're also able to navigate backwards using the B key, for examples. So we can go forward with F, backwards with B, just as we can do with less. Less is the same thing. Changing more to less, for example, does the same trick. But notice one slight difference. Less does not show the percentage as you navigate through the document, but allows you to advance and rewind through the document as you see fit. But again, all of this is premised on having the appropriate permissions to the file that you're interrogating. So use ID to determine who you are on the system. Let's just SU back in for a moment and confirm our membership. Now, notice that when we SU in as root, the UID has switched from 1000, which is the first UID on Debian for non-privileged users, to 0, which is always the UID of root on Nix-based systems. And the GID has also been changed from Linux CBT's GID of 1000, which is the same, to a GID of 0. And we see that the user root belongs to the group root. And because the user root belongs to the group root and is root and has a primary GID of root, the user is able to interact with any file on the system, thus obviating the need for these group memberships, which permit access to devices such as Bluetooth, scanner, net devices, plug-in devices, floppy, CD-ROM, you name it. So in other words, interacting with the system with various hardware devices. So that's more, less. We've talked about touch. We've also talked about using catenation. Let's also talk about some other features surrounding the bash shell. So we'll list this as a 24th feature, and that is the ability to write output, so stdout. So the ability to influence output to a location other than the screen. Normally with computers, output is sent to the screen or the hard drive. The way we send to the hard drive, which means to a file as opposed to the screen for a command that would normally send to the screen, is to use the greater than symbol. This symbol redirects information to a named file. So for example, supposing we wanted to cat the contents of var log messages, let's say the first 10 lines or perhaps the last 10 lines using head or tail, and dumping that output into some other file. That's an opportunity for us to use output redirection. To enumerate this information, we could use head, for example, for the first 10 lines of var log messages. So there are the first roughly 10 lines, if it's configured to 10, it should be, of var log messages. But supposing we're taking snapshots of the first 10 lines from a number of log files in an automated fashion, and we'd like to redirect that output to some other file for post-analysis. Then using output redirection, greater than symbol, we can then send that output to a file such as temp. Let's see if we've got temp created. We don't, so we'll just send it locally and then move it after. So we'll send this to first 10 lines. So first 10 lines of var log messages. Notice the suffix is not required. Whenever you execute a command, whether via a script or manually, echo the exit status so that you are assured that the process did what it was supposed to do. Now we have this file, first 10 lines. So this particular file contains that output because we've redirected it. Again, in its normal state, head displays the first 10 lines to standard out, which is the screen. But using output redirection, which is a single greater than symbol, we're able to influence where those first 10 lines have been sent. So that's output redirection. Now supposing we wanted to take a snapshot of another file, or the same file, let's say the last 10 lines, and place it in the same file. That's where append redirection can be helpful. So this is append redirection, which does not clobber target file. The difference with normal redirection, standard out redirection, is that it clobbers the target file. Now let's just show you what we mean. If we rerun this head, you'll see that it'll overwrite the file. First, let's stat first 10 files, 10 lines of var log messages. Pay attention to the timestamps associated, 1652:39. Those are the timestamps associated with first 10 lines. Now, if we head again, sending with output redirection first 10 lines, we'll see momentarily that the file will be clobbered. So let's try that. Let's restat it. Now notice that the stamp has been updated. It was accessed 1652. It's the same file, but it's been truncated and updated at 1654. So just under 2 minutes later, the file has been updated. So a single greater than symbol clobbers the target file, whereas double greater than symbol appends to the file beginning with the first free line or at the end of any existing data. So for example, double greater than symbol, and now when we take a look at the file, well, first of all, the file is now much larger. Instead of 950 bytes, it's double. It's 1900 bytes because the data are the same. And then when we cat the contents of the first 10 lines, it's no longer the first 10 lines, although it really contains 2 copies of the first 10 lines, which leads us to another useful command, and that is WC. So oftentimes you're dealing with textual data in Linux-based systems, and you need to quickly ascertain the number of lines in a document. If you use WC, that'll help you. This program is normally used to count words, but can also be used to count lines. So word count and optional line count, which is how I like to use it often. So WC-L followed by file name counts lines. So now let's try that. WCL, first 10 lines, and notice it actually contains 20 lines. And that is because, of course, we used append redirection to build the file twice. So WC-L is useful for counting lines. So for example, WCL, var log messages, will give us a sense, and rather quickly, just under 4,000 lines, 10 short of 4,000 lines, are in that particular document. Of course, for larger files, it'll grow accordingly. So we've got clobber redirection, output redirection, append redirection, which does not clobber. Again, we can continue to append, and the file will just continue to grow. So head, and now we should be at 50. So let's WC-L, and we should see momentarily not WCL of varlog messages, but WCL of first 10 lines. So let's try this out, and we'll just WCL first 10 lines. It's now up to 50 lines. Now the converse of head is tail, another important command because it starts from the bottom of the document. So tail, and we actually did not document head, so let's just note head and tail. And let's just note that it extracts first/last 10 lines of target file respectively. So for example, head var log messages, and similarly tail var log messages. This always begs the question surrounding multiple files. So tail var log messages takes the last 10 lines. How do we know these are the last 10 lines? Well, a number of ways we can tell. Compare it to your current time. So 1606, 1656, it's currently 1657. These lines must be the last 10 lines at the point the command ran. On a busy system, that may not be the case. And of course, we can then use append redirection to send to the first 10 lines and then just rename the file if appropriate. And now when we WC-L first 10 lines, it's up to 60 lines. Now, what about multiple files? Let's navigate into var log messages. There are a number of log files here, var log that is, that's one of the files. There are a number of files including messages. Supposing we wanted to head a number of files. Well, we've got messages, and we've also got directories for different programs like Apache 2, apt, and other items. So supposing we wanted to look at the mail log, but the mail log's empty, so we need something else. So messages is one, and we've got another candidate, perhaps the syslog file. So let's head syslog, and there are lines from syslog. So now let's head syslog as well as messages. So what's happened in the output? Notice that head was nice enough to tell us the data that come from the various files. So this data come from the syslog file, and these data come from the messages file. So you can indeed use both of these. Now, how does this impact the output? Let's send it to LinuxCBT. By the way, you can reference a user's home directory with simply tilde and the name of the user, and then tab the user's name out. So LinuxCBT, and we'll call this first 10 lines, same file, and let's use append redirection. In fact, let's go with clobber redirection so we can see it clearly. Now let's change into LinuxCBT's home directory, and we'll WC-L first 10 lines. It contains 23 lines. Let's less first 10 lines, and notice the demarcation is included to reflect the sources of data. So if you're parsing with some sort of scripting mechanism, then you'll have to take that in account to be able to parse that information out so it doesn't end up in your target document for processing, for example. Now there are a number of other commands. One other command that we'd like to get to, and we'll get to many others informally, is, for example, let's take a look at sequence. Now oftentimes we need to generate sequences. So generates sequences of numbers. This is an important command, especially as you get into scripting, because oftentimes we need to have the shell script do something n number of times. This is the key command. So a simple execution, sequence 10, generates 1 through 10. And that's quite simple to understand. So let's SU or drop privileges back to the user Linux CBT. Let's do a which sequence. Sequence is not available, by the way, on many distributions by default, so you may have to install it. For example, Mac OS X, Solaris, etc. So if you're on a distro that doesn't, then just get a copy of sequence. So sequence 10 dumps 1 through 10, and ditto for 100. And it also allows stepping. So for example, sequence 11 through 20 enumerates 11 through 20 inclusively. This is powerful because if you need to do something, let's say 10 times, then that's the idea. You can wrap this into a loop using a for loop, which brings up another bash idea, for example, or shell scripting idea. So for loop. So oftentimes we need the computer to do something multiple times. So for example, for a variable, the most famous variable, should have its own star on a walk of fame, perhaps is the I variable, or a variable named I. So for I in sequence 10, this basically will do something 10 times. And the something is placed here, and then we're done. This command will do whatever you tell it to do 10 times. So what's happening here? For I in, so for each iteration through this loop, notice the backticks. The backticks are achieved by using shift and, or non-shift that is, and the symbol next to, or the key to the left of the 1 key. This is one way of using command substitution. It's a feature of the bash shell as well as other shells like corn shell and otherwise. So I will become whatever sequence 10 happens to be at the moment. 1, then 2, all the way through 10. And for each iteration through the loop, it'll do whatever that something is. So let's echo hello world. This will echo it 10 times. And once it does it 10 times, then we can start to use the variable and do more sophisticated things like nest loops to do other things, for example. And this didn't copy it, as it often doesn't, because we hit the wrong key. But nonetheless, let's try to paste this again. So we'll for I in sequence, and let's just check our syntax. Sequence 10, do echo hello world. Our semicolon was in the wrong place. Done. That should be it. So let's just fix our semicolons right after the sequence initiation, then the command. So there we see 10 hello worlds. Now the variable is changing through each iteration, and we can capture that by just referencing the variable. Echo will echo the variable, so 1 through 10. And now we can do more sophisticated things because of this simple sequence generator. And we can do this as many times as we need. For example, sequence 15 through 20, or 14 through 20, and it does it 14 through 20, or something through a million. This allows us to do all sorts of things that are loop driven in the shell, and then eventually wrap them into scripts. So building simple for loops is very important, and an important part of that is using sequence as your command to generate a sequence of numbers. Let's just show you, by the way, this backtick notion. So note, backticks provide a way to execute command substitution feature of bash shell. Another way is as follows. In between parentheses, execute the same command. And echo hello world, I, done. This is yet another way to execute the same command. Let's drop this W here and try this out. And we should see momentarily that it performs likewise. So indeed, so two ways of executing command substituted commands, using $, nesting or wrapping, or enclosing your command, or using backticks. Either or will work. So we've covered a number of commands. There are many, many more commands to go. We've looked at df, for example, using the human readable format, which enumerates the file systems that are mounted, including udev, which performs automatic device detection for us, the virtual tempfs, as well as the root file system. So df-h, let's just note 29 df enumerates partitions / file systems that are mounted. Another important command is simply mount, and we'll just indicate double quotes that it performs likewise. Mount shows us the partitions and file systems that are available. So dev-sda1 is an ext3 file system that's read-writable. If there are errors, it'll be remounted as read-only for us to troubleshoot. Tempfs, the proc file system. Mount shows us more than df. Proc file system, which is a virtual file system maintained by the Linux kernel. Fuse support, which allows non-privileged users to mount other types of file systems that were once only mountable by root. So mount is another important command. Yet another important command, free, enumerates memory allocation. This includes, of course, RAM and swap. So we normally use these commands that return storage information with the human readable forms or options of those commands. For free, it's the M command. Otherwise, the commands tend to enumerate in bytes or kilobytes. So free mem. So this instance has a gig roughly, and it's using just under 300, of which 70% roughly is free. And of the swap partition allocated 465 megs, all of it is free, which means the bulk of what the system needs to do is happening in memory. So it's running optimally. So free is yet another command that is of the utmost importance in terms of helping you to determine what the memory utilization is like at any given time. Yet another important command is the ps command. Although you have GNOME System Monitor, ps enumerates, let's just drop this B, running processes. When executed as a non-privileged user by default, or as any user by default, enumerates the processes tied to the currently running user. So this sudo terminal is sudo terminal number 1, and any commands that are running in sudo terminal 1 are returned when we execute the ps command. So ps by default enumerates running processes. And let's just note, ps default shows processes of current, let's just capitalize this, TTY. So as a root shell, let's su in and run ps, and notice the same thing. This root shell has su, bash, and ran ps. Each PID is shown, the PID, the process ID, and to which TTY it's tied. Now, not all processes are tied to TTYs. You can run programs, for example, one that comes to mind, LFTP, can execute uploads and downloads sans a TTY. They may have begun life on a TTY, but not be any longer attached to one. And also, commands that are executed by cron in the background may also not be connected to a TTY. So the TTY processes are enumerated. Here on sudo terminal number 2, ps shows processes that are tied here. So su, bash, ps, and over on sudo terminal number 3, similar situation. But as we use ps with options such as AUX or EF, which is more familiar for those familiar with Solaris, we see processes of all of the users on the system, including root. So we see that root has the bulk of the processes, including init, the main process, and all of the subsequent processes that were started to get the system up and running. So since this server has Apache running. We see a number of instances of Apache running as a non-privileged user, www-data, as well as a DHCP client to get an IP address, and wireless support, GDM3, you name it. A good deal of these processes run as root. The getTTYs run as root that are bound to the terminals that are available on Control-Alt F1 through F6. Most of the programs run as root, but once you launch a graphical environment, then all of a sudden you start to see a number of programs that are bound to the user who is connected, in this case Linux CBT. So PSAUX or PSEF shows you much more information. So PSEF or AUX enumerates processes of all users on the system. The difference between the two is the way in which the information is presented. For a quick comparison, PSAUX in this window, scroll to the top, you'll see the column headers. So for example, with AUX, you get user PID, and you get the same thing, UID PID with EF. But then you also get the percent CPU, percent memory, virtual size, so you don't get percent CPU, percent memory with EF. You also get the start time, and you get the start time as well. It's called S time with EF. And you also get TTYs on both, which are important. Notice the question mark for these processes that were launched by init. None of them are tied to a TTY. Some processes, like the getTTYs, of course, are tied to a TTY. The pseudo terminals are tied to dynamically generated pseudo terminals or terminals managed by the GNOME desktop environment. So again, there are a number of commands that are of importance to you, many more that we've yet to cover, but we will touch on them as we move throughout the system. We've touched some of the key ones, as we tend to do with our operating system releases, as they are important because they help you to navigate Linux systems rather freely. So let's go ahead and save the documentation and move on to some other areas of interest.